It's 29th September and monsoon had taken a break for a few days, maybe a week. Now it's raining very nicely today here in Mumbai. And talking about rain, this is a nice paper from Manu Lal's group from Columbia University, which takes a different view on how to solve the groundwater depletion problem in India, as well as enhance food security and general income from food production, grain production. The pattern of kharif crops, for example, shown here with for rice, pulses, oil seeds, and other cereals, especially wheat over here, hasn't evolved over time based on some optimal climate calculations. They were mostly an outcome of India trying to solve the problem of droughts and famines in the 1960s and the Green Revolution that followed, and then the infrastructure like canals and dams that got built to keep the cropping patterns going, and over time not paying attention to whether this is optimal, not only in terms of groundwater depletion and what may happen in the future in terms of climate change, and where the ideal locations in the country may be for rice versus pulses or oil seeds and so on. So this historical baggage has been addressed in various ways. There are papers from Ruth de Vries's group which look at crop adaptation in the context of how climate will change and how crops have to shift, maybe bring in more millets, more climate resilient crops, and so on and so forth. In the meantime, the groundwater depletion for continuing with these existing cropping locations is extracting groundwater at a rate of several meters per year in some regions, which is obviously not sustainable. So this paper from Manu Lal takes a different approach. It uses cropping model, economics kind of model, optimization, to argue that the public distribution system and procurement regions for each of these crops that the government is running can be changed so that the optimization can be done in terms of how to go after either no irrigation or a capped irrigation, because right now irrigation also is exacerbated because there are subsidized electricity incentives offered to mine groundwater, and the groundwater levels keep dropping, and deeper you go, the more you are pumping, more energy you are extracting, and then there are other details of contamination from arsenic and other things. So this is a rather unique approach. What they do is point out that in fact where some of the crops are being grown, like rice and other cereals, are in fact in the regions where rainfall is low in the mean during the summer monsoon, and they don't get winter monsoon here. And the variability is very high as well. So these are about the worst places to be the bread baskets of India. This is of course the desert of Rajasthan, but Punjab, which is generally the bread basket of India, lives with this high variability in rain, but the crop production often is independent, or the water use, groundwater mining, is independent of how much it has rained, because people are pumping water and irrigating even if there is a good amount of rain. So these are kind of the complications one has to deal with. Using this model, basically the paper here concludes by comparing of current versus optimal national revenues, crop production, and nutritional value. So they are trying to save groundwater. Of course it comes with energy savings and also food security, also in terms of total crop production, incomes versus nutritional value. So this is current versus optimal national agricultural revenue. So in the current conditions, current practices with the public distribution system and the procurement system by the government, with the current cropping patterns, it is around just under 3 trillion Indian rupees, and the optimized approach they're proposing, they consider two scenarios: irrigation zero and irrigation capped. This is a modeling exercise, so obviously there are many assumptions involved, and this is not so much focused on climate change. It is just taking the mean climate in the current system and then looking for how distribution of procurement locations can change water use, electricity use, and grain production and national agricultural revenue. So you can see that irrigation zero scenario increases that a tiny bit, but irrigation capped can bump it up quite a bit. So optimized irrigation kind of work have been considered at global and regional scales, but implementing them actually hasn't been that successful, and also moving crops have been so successful. So even though this paper is great, we still have to worry about this as a good strategy, but how will it be implemented? Okay, so in B we are looking at current versus optimal national production levels in millions of tons for rice. So it doesn't make much difference in current irrigation zero or irrigation capped scenarios, but other cereals are also similar. They are lower in India is a big rice consuming and rice exporting country, so obviously that's very high. Other cereals are about a third or less of that. Pulses, you can see that in the model that is being optimized, being used here for optimization, the pulses more than double in terms of national production, and similarly oil seeds also increase more than double in the irrigation zero and capped irrigation scenarios. So irrigation zero obviously will save a lot of energy, but one can also think of the opportunity cost. So if you make this choice and you focused on saving water and electricity, then you are losing potentially higher yield, higher grain production. So that opportunity cost is also calculated, and it shows that there are many states which can benefit from reducing that opportunity cost and making a choice of irrigation capped versus irrigation zero, for example. We'll see a figure in a minute. The nutritional value, energy in kilocalories, current intake, this is the recommended intake. Current intake is already higher. With irrigation zero, you reduce the current intake, but you're still in the recommended intake value range. And this is important because obesity, food waste are obviously a big problem in India as well. And if this can save water and reduce overeating, overconsumption with the expanding middle class, then that would be good as well. But with irrigation capped, again, nutritional value goes up relative to recommended intake. So irrigation zero irrigation, so this is for folate in micrograms, so energy and folates. Current so D is current, and current versus optimal nutritional value for proteins, fats, iron, and niacin, which is an acid that's essential for cell functioning and so on. So for nutritional recommended values also are shown here in each case: proteins, fat, iron, and niacin. And again, there are some improvements made. Of course, consuming too much protein compared to recommended intake, is that good or bad? We have to worry about that. Fat, of course, fortunately current intake is lower, but this is probably averaged out over very poor people who consume much less than recommended, and very rich people who consume much more than recommended. But nonetheless, irrigation zero and irrigation capped scenarios increase the fat consumption here, and iron is also improved with irrigation capped, and same for niacin. So you can read the paper for more details. So the recommended changes or optimization strategy in terms of procurement, water use, groundwater depletion, and energy use are like this. These are relative changes in areas in Kharif season compared to what's happening now. So in the optimized scenario for irrigation zero and irrigation capped, for rice, for example, there are regions where the current regions have to be reduced in some places, so that those are the negative numbers, and they can be increased in some other regions, like here in Karnataka, Madhya Pradesh, Northeast up here. So this is for irrigation zero scenario, and this is for irrigation capped scenario, and you can see the differences over many places, especially here, for example, in Karnataka and Madhya Pradesh. Other cereals, irrigation zero, irrigation capped, again some changes in areas, some increases, some decreases, so there is redistribution of where they will be grown so that government can plan procurements along those lines as well. Similarly for pulses, oil seeds, and so on. So this can translate then into net gain in income in trillion rupees Indian. So irrigation zero scenarios, the greenish colors are increases and reddish colors are decreases compared to the current income levels. This is the for irrigation zero, and the net gain in income in trillions is for irrigation capped. You can see that there will be some losses, but energy saved will be very high for net zero and irrigation capped. So you are optimizing things, and you are also saving water here. Water saved in billion cubic meters in irrigation zero scenario and irrigation capped scenario. Obviously, when irrigation capped is compared to irrigation zero, you are using more water here, but you are still trying to optimize crop distributions and water use and energy use, right? So the crop distribution changes required for climate change adaptation and so on have been done as well, but those are mostly for rain-fed agriculture and not so much for all crops that include irrigation as well. So this idea here is to extend the crop selections to improve groundwater depletion situation as well as improve net income, and also look at nutrition that results from doing these things. So here is water saved from irrigation cap. The opportunity cost in trillions again for irrigation zero and irrigation capped. Again, opportunity cost is basically if you chose option A and you look at option B that you had that you didn't choose, what would have been the outcome if you chose B? And if this is less than option B, then you are obviously paying an opportunity cost by saving energy and water but reducing your income overall and so on. So there are many states which will benefit. So here are the positive numbers for irrigation zero and irrigation capped. So some states are paying an opportunity cost, so they would benefit from going from, for example, irrigation zero here, opportunity cost is higher than irrigation capped. So doing optimal capped irrigation will reduce the opportunity cost for the state here, which should be Andhra Pradesh and Telangana combined. They have split recently, and Karnataka as well. Okay, and of course Punjab shows up in all these cases as well. Okay, so let's just read a few words about the discussion. India's public distribution system can be seen as a version of contract farming, in which a farm producer and a buyer agree on terms for the quality, quantity, and price for what is to be grown. So there is a base price set which is supposed to be above the production cost. The Indian government has demonstrated that this is a powerful tool for shaping crop choices and integrating technology, financing, and appropriate inputs like fertilizers, water, and insurance instruments to support rural economic development while meeting the food security and nutritional needs of 1.3 billion people. So there are issues, of course, about loan sharks, farmer suicides, going after crops like sugarcane or cotton in regions which don't have enough water for it, but we are already talking about rice being grown based on the old evolution in places where it's not optimal. It's extraordinary. It is an extraordinary success story for a country plagued by famine when its population was 300 million in the 1960s. Over time, the intensification and concentration of agriculture to support the PDS goals have led to poignant environmental and water resource sustainability concerns. Finally, it's kind of interesting that they have actually had discussions. So at the level of impact, our discussions with farmers in Punjab and Gujarat indicate that they would welcome returning to traditional or other crops grown in those areas with government procurement at a cost plus margin, which is the same as the current public distribution system. There is an expectation that the government would also support these measures through research, agricultural extension, technology, and financial measures to increase the productivity and reliability of production of alternate crops. So every time you ask farmers to change their ways, move to a different crop, you have to somehow incentivize them, provide guarantees on prices, technological support, financial tools, extension services which gives them good advice, and so on. Thus, a refocusing of the public distribution system could indeed allow India's government to facilitate the transition to a sustainable water, energy, food future. In our analysis, we accounted for the historical climate variations. So they have looked at how the optimization is done in the context of what has been happening in terms of monsoon mean and variability, decrease, extremes, or so on. Climate change projections for the 21st century continue to be somewhat uncertain. Consequently, an adaptive strategy that considers 5-year plans and associated climate change scenarios would provide a robust strategy for moving toward a sustainable future. Our future research endeavors will continue to address these. Okay, nice paper. So even though I didn't go into the details of the models, which you can read up if you're interested, I did want to give you a sense of how this approach is taken to reduce groundwater depletion, ensure food security, and increase income as well by redistributing crops and the associated issues with them. Of course, when information is co-produced, it is much more likely to be used more. So they have talked to the farmers. There are all kinds of changes being proposed, like moving to millets, not only for farmers but also for people to consume, because if you grow millets and nobody is buying them, that's not going to work, and so on. Okay.